This conference will now be recorded.
Okay, so in a continuation to what we were studying yesterday, we are talking about, one second, hello. So in a continuation to our Docker session, we told that Docker will be managed properly if we start using Kubernetes. So the platform was all set for this guy called Kubernetes, because first, when we started our journey, we were dealing with traditional deployments. We had our own hardware, we had our own operating systems, and we used to own the data centers. But then gradually we moved to a virtualized deployment where we started using virtual machines or VMs. But VMs were tough to manage because of the hypervisor thing. They had their own operating system and they had a lot of problems. So they used to consume a lot of space and all those things. So I moved ahead and went to the container deployment where I started using Docker containers and I started using Docker engine and things were working smooth for me. But from there, as and when the usage of Docker started becoming more and more people switching to microservice based architecture, it seriously became a challenge to run these many Docker containers, manage them, load balance. Whenever there is a failure, go ahead and do a health check. So all these things started becoming very complex. And in the previous class, we saw that somehow this guy Docker Swarm was not able to cope up with the enterprise level workload which we were having. Seeing this gap, Kubernetes jumps in and rules the market. So when I say Kubernetes jumps in, why did Kubernetes come into picture first of all? Or what is Kubernetes first of all? So Kubernetes was an in-house project of Google, which Google was using for its own internal work. But then it saw that there is a huge gap in this market and it just came up with that stuff and donated it to CNCF, Cloud Native Cloud Foundation. So it's a community of set of developers and people who manage all the open source software. So something which is free of cost, something which is backed by Google, gained importance like anything, gained popularity like anything, and people just grabbed this Kubernetes with an open arm. So the microservice based architecture which we were trying to implement started running on Kubernetes. As and when people started using Kubernetes, they saw that Kubernetes is really working like a magic. The entire orchestration is done very smoothly. Yes, the configuration part was difficult. Initially, when you start, the configuration is difficult. The ways of working of Kubernetes is difficult. But then once you get used to the ways of working, you can simply enjoy working with Kubernetes. When I talk about Kubernetes, I will talk about Kubernetes cluster. So whenever I say Kubernetes cluster, I'm talking about a master slave architecture. In a master slave architecture, I will have multiple masters and multiple worker nodes. So when I say multiple masters, in a simple prod setup, you will have 3 to 5 masters and 10, at least 10, 5 to 10 number of worker nodes. So you can imagine the workload which they are going to tackle, they are going to capture. So one thing which I made clear here is that Kubernetes work on master slave architecture. So this is one thing which I clearly told you here. There will be master node, n number of master nodes, and there will be n number of worker nodes. Worker nodes whose work will be to manage the work. This is the place where the actual containers will be running, and masters are the one who will be doing the management activity. They will manage the servers, where it is going, how it is going, and all those things. When you want to install Kubernetes, now Kubernetes being an open source tool, it can be installed anywhere. It can be installed on your cloud environment, it can be installed in your local machine, it can be installed on your Azure platform, AWS platform, anywhere and everywhere Kubernetes can work. And that's the reason each cloud provider has come up with its own variety of Kubernetes. When you go for Google, Google comes with something called GKE, Google Kubernetes Engine. Amazon comes up with EKS, Elastic Kubernetes Service. Azure comes with something called AKS, Azure Kubernetes Service. So every vendor, not only cloud vendors, every vendor has their own version of Kubernetes because Kubernetes is free of cost and nobody is charging anything for that. So based on the Kubernetes engine, they put a wrapper of their own services and they sell it as a service. But the internal engine still remains the same. Now, I told that Kubernetes is working on a master-slave architecture. So definitely there will be a master and there will be n number of worker nodes. So when I say master, a master machine or a master process will basically have these four major components. It is very, very important to understand who is doing what and what actually they stand for. Okay. So as a client, you may update or run a query to the Kubernetes cluster machine, to the Kubernetes cluster. So this request, whatever you are putting on the master machine, will go to the API server. So API server is the component which will check for the authenticity of the request. Whether the one who is requesting is an authentic user to make a request, whether it is a correct request. So it acts like a gateway and allows the request to be validated. If the request is a genuine one, it moves it ahead. Okay. So API server is the first component who is validating the authenticity of the request which is coming in. And if it is authentic one, it will move it ahead. Then I have something called scheduler. Now scheduler is something which will see what request came in. Okay. And it will simply, or before even going to scheduler, the request will go to control manager. So control manager is one who will say what's happening, okay, or what's there in the request. So whatever is there in the request, we say it's a desired state, means what you actually want to do. Then you have something called etcd. So etcd is the brain of this cluster. So what are these pods doing? How much they are occupied? All the details are present with this etcd. So it's a key value store which contains state of the cluster. Means you can think like a database. This is a database which says this guy is 60% occupied. This guy is 30% occupied. On this node or on this client or on this worker node, 3 pods are running. On this worker node, 5 pods are running. I can put 3 more pods here. I can put 5 more pods here. So all those details, okay, can be stored here on the etcd. So whenever API server is receiving a request, it will, which one is the cluster in this diagram? So as I told you, cluster is the entire thing. So when I say cluster, it computes of master plus worker node or master plus your slave node. So I'll take a step back here. So I'll take a step back here. So if you see this carefully, these are the master nodes. Okay. And these are my worker nodes, or you can say slave nodes. Okay. So master node is the one who will do the management activity. It will not be doing the actual work, but the actual work is being done by these worker nodes. Okay. When I say cluster, I just want to say that cluster is nothing but it's a combination of master and worker nodes. The number of master machines, the number of worker nodes will completely depend on the workload which you are having. So if you have a bigger workload, you will have a bigger cluster. If you have a smaller workload, you will have a smaller cluster. So whenever I say cluster, I mean a combo of master and the worker node. So if you see carefully, master has different set of components, worker has different set of components. Coming back here, When I talk about master, I'm talking about these four components majorly. Out of these four components, the gateway or the authenticity of the request is validated by my API server. API server sees what request is coming in, what is the user wanting, what does he want from me, what is his request, is he the valid guy to make a request, is it a valid request. So those kind of authentication and authenticity will be done here. Authorization will be checked and the request will be forwarded to my control manager. The control manager will quickly go to etcd and say what is the current state, is what is actually happening here, what are these guys doing, I want to know. Like a manager, he will go to the team lead and he'll say, tell me what's happening, what are your resources doing. So what are these resources doing, the thing is already updated here in this etcd cluster. So always this etcd will store the latest state of my nodes. Are these nodes available, are these nodes not available, are these nodes fully occupied, how much space they have, what work is going on. So all those details, okay, will be basically stored here in the etcd, and it is stored in a key value format. So we say that etcd will store my actual state, what is actually happening. So etcd will always have the actual state. This is my desired state. This is what I want from my cluster. The end motto of this guy is it wants to match the actual and desired. Okay, so when actual and desired has to be matched, who can do it? First, I should know what is the desired state. Who will tell me that? Let me just delete this. 1 second. Okay, so this guy is telling me the desired state. This guy is telling me the actual state. And this guy has been given the task of letting me know or of making this happen. Actual equal to desired. So first, the control manager comes to know the desired state from my API server and my actual state from my etcd. And then it instructs my scheduler to do the task. It can be like deleting 2 pods or creating 2 more worker nodes. So whatever is the activity done, control manager will go and command to my scheduler, and scheduler based on its availability will schedule that activity. Okay, I'll repeat once again. So in Kubernetes, I work with master slave architecture. In master slave architecture, I can have n number of master nodes and n number of worker nodes. It will totally depend on the workload which I have, how many masters I'm going to have, and how many worker nodes I am going to have. But bare minimum, the expectation is you can have 1 worker node and 2 master nodes. This is a bare minimum expectation. People go even beyond, even below that. But bare minimum, the expectation is 1 master, 2 worker nodes. So you need 3 machines altogether, 3 machines to set up a cluster. Once I have a cluster ready, okay, I will tell one of the machine, or I will assign one of the machine as master node and the other 2 as worker node. Worker nodes are the one who will actually do the work. Containers will be running on the worker nodes, and the actual work will be done by my containers. Okay, but I need someone who can manage these containers. So when I say manage these containers, the container management, the orchestration work will be done by my master node. In my master node, I have four major components: API server, who is validating the request, who is checking authenticity of the request, and passing it on to the control manager. Control manager is the one who is checking the desired state from the API server and taking the actual state from my etcd and saying what is the difference. What is the Jenkins, I'll come back. Just let's concentrate here. Jenkins, I'll come to that later. So Jenkins is a different software altogether. Think it like this. There also, the master is taking the work and distributing it to the worker node, but that is at a very low level, I will say. When you talk about Kubernetes, it is done at a very high level, or a very standard level, I will say. Not high level, very standard level. Okay. Okay. So in my client, so whatever client I'm using to connect to my cluster, this client will send a command. It will be validated by my API server, goes ahead to my control manager. Control manager gets my desired state. Control manager goes back to etcd, collects the actual state, sees what is the difference between desired and actual. If desired and actual are same, it will not do anything. But if desired and actual are different, so let me say desired is that I need 3 worker nodes, but the actual state is only 2 worker nodes are available. So it will quickly go and say to my scheduler, schedule 1 more worker node here. Other way around, the desired state is 1, but the current state is 2. So it will delete 1 instance from here. So based on what command it is getting from my control manager, it will go ahead and do the activity. So scheduler will do that activity. These are the 4 components which you find on the master node. On the worker node, you will find something called pod. Okay, pod is nothing but it is a smallest unit of work on Kubernetes. So Kubernetes do not directly deal with Kubernetes do not directly deal with containers. So let me say if this is a container, one second. So if you see here, container is the innermost, or this is the one who is going to do the actual work. But on top of container, Kubernetes will put a layer of abstraction called pod. Okay. So in Kubernetes terminology, if I have to talk, I will say pods are actually doing the work. Or if I go deep inside, I will say containers which are running inside the pod are doing the work. Okay. And this is my setup. If I go to internet and say Kubernetes architecture, so it is very important to understand each component of Kubernetes. Trust me, if you understand each component of Kubernetes in depth, things really become very easy for you. So if you see this diagram, you can see here that there is a developer or there is an operator or there is a client who is requesting something from my API server. I told this API server is the one who will validate the request, whether it is the correct one or not, and it will allow it to go inside. First, this request will go to my control manager, which will check my desired state and actual state with the help of this etcd. Once it has those details, it will go back to my scheduler via API server and say, I need these things to happen.
So these are the 4 components on my master. Coming to the worker node, on worker node, I can see there are something called pods. Pods are the components inside which the containers are actually running. So pods are the abstraction or the layer inside which the containers are running. But when you talk about Kubernetes, Kubernetes is not directly dealing with Docker containers. Rather, it is putting a layer of abstraction named as pod and then dealing with pod. So we say pod is the smallest unit of work on Kubernetes. Pod is the smallest unit of work on Kubernetes. So this is pod. Now, because these are on the same cluster, they are interconnected. Ideally, it is said that one pod should have one container. But if you want, inside one pod, you can put any number of containers. But in ideal scenario, it is always said one pod, one container. If you do one pod, one container setup, managing this cluster will become easy for you. But if you start keeping a lot of things, no, it will become complicated. So go with the thumb rule, one pod, one container. Then on the worker node, you see something called kubelet. Now I told that my my etcd will have the knowledge. It will know who is doing what, which pod is running, which pod is not running, which is healthy, not healthy, occupied, not occupied. How it will know? So on worker nodes, there is something called kubelet, which will be constantly updating my etcd. Okay, so here the pointer is pointing to this guy, but no worries. Kubelet is constantly going and updating my etcd. It is telling me, see, I am 30% available. I am healthy. I have 3 pods running on my worker node. So all these details are constantly being captured by etcd. Then if some external user directly want to come to the pod, okay, directly they want to come to the pod, they will come via kube proxy. They don't want to follow this channel, but they directly want to come to the pod, they will use kube proxy. Okay, so to summarize everything, Kubernetes works on master slave architecture. In master, I have 4 components: API server, scheduler, controller, and etcd. API server is the gateway or the main component of this entire cluster. It takes care of the authenticity and authorization part and allows the authentic request to come inside. Once the request is received, it goes to my control manager who checks what is the desired state and the actual state. If the desired and actual state are same, no activity will be done. But if the desired state and actual state are different, it will go and instruct the scheduler to perform that activity. How it will know what is the desired state, what is the actual state? So desired state it is getting from the command which is sent by the developer, and desired state it is getting from etcd. etcd in turn will connect itself to the worker nodes via kubelet and take all the status updates from them and put it here in the etcd. So always etcd should be up to date. If etcd due to some reason is not up to date, you will see your pods or your cluster will crash. So this is there. Then you have something called kube proxy, which will help you to help your users to direct connect to the kube, to the worker nodes. And then you have pods inside which the containers are actually running. Okay, any doubts, any questions till this point of time? It is very important that you understand each and every word of what I have told right now, because I will say if I'm having a construction work, I'm just starting with the basement and first floor. I'll build a 10-story building. So to build this building strong, the foundation should be very good. So in this context, if you have any questions, anything, please let me know. You can put it on the chat window in case you have the questions, I can take it from there. Okay. Do they do the same thing with Jenkins? Now, when you talk about Jenkins, okay, Jenkins is a different software altogether whose work or the architecture is very similar. But at the end of the day, Jenkins has a different set of work to do, and Kubernetes has a different set of work to do. Kubernetes is mostly or largely going to deal with containers, whereas Jenkins is mostly or largely going to deal with jobs. So if the jobs or the activity increases, Kubernetes will park some job to the worker node and let it work. It is like I have, let me say, I have ordered 10 burgers. Obviously, I cannot finish it single-handedly. So I invite another 5 friends of mine. So Jenkins is like that, a small task like eating burger. But if I host a party, okay, and I have to cook food for 50 members, okay, and I cannot go and order from outside. So I need more helping hands. I have to do a lot of work. In fact, to do this kind of work, I need experts because cooking food for 50 members is really a difficult task. Okay, coming, you get an invitation, you come to home and you eat and you go is a very easy thing. So that is on Jenkins side. You get a job, you do the job, and your work is done. But here you have to be expert to get into the cluster, do the work, and do it effectively. So two different things. Yes, both have same master slave architecture. Yes, definitely you need both. There are two different things which they will be doing. So when I say Kubernetes, it is a container orchestration tool which will help you to manage your containers. And when I say Jenkins master slave, it is more of a individual task which is to be distributed, something like that. But yes, both are important. Now, if you see this nominal setup, one master and two worker nodes, you will need at least 3 machines to work on this. Not everybody will have 3 machines to get started. Kubernetes understands this. So what it has done is it has given you a component called Minikube, a machine in which everything is inside one machine only. Okay. This Minikube is a software which is basically a virtual box, and inside this one machine you can create your cluster. It means master is also here, worker is also here, pod is also here. Every setup is done inside one single machine. So to start with Kubernetes, the best way can be to start with Minikube. So Minikube is basically used for testing kind of activities. You just want to get started. You want to get the look and feel. You don't want to create the cluster right away because creating cluster can be complex. I want to first get the look and feel. I want to be a developer and interact with the cluster. I want to see how the cluster looks like. So you can come here and say interactive, interactive Kubernetes shell, or you can say interactive Minikube. So when you say interactive Kubernetes shell, it takes you to the official website of Kubernetes and you can open a terminal here. So it's an online portal where you can run all your Kubernetes related commands. So if you come down here, you will find it. One second. Come down here. So interactive Kubernetes shell is what I'm looking at. And I get a screen like this. What I have to do is, so it's a pre-configured thing. You don't have to do anything. You have to just maximize this. Come here and say Minikube start. So Minikube is a single machine on which everything is installed. So basically it's a Ubuntu 18.04 OS. It's giving you some 2 GB RAM, okay, 2-core CPU, and it is running Kubernetes 1.20.2 and also Docker is installed. Okay, so basically whatever you need to get started is present here, pre-configured here. Why is this being given to you? So that you get started. At least in the very beginning you don't get scared. So it gives you everything what is needed: a good operating system, a latest Kubernetes engine, a Docker engine pre-installed, kubelet, if you remember kubelet from my architecture, kubectl, all those things are already pre-configured here. So it says booting a control plane, so it is trying to create a server for you. And on this single node, on this single machine, you will get everything. Wait for some 2 minutes, it will get activated. Yeah. So configuring local host environment, verifying Kubernetes component. And it is taking the latest Minikube image from gcr.io. So it is Google Kubernetes registry. From there, it is pulling this Minikube thing. On top of that, if you want to install Minikube on your local machine, that can also be done. I told this can run anywhere, right? So if you come here and say Minikube install or download. So, yep. So you can install Minikube. You can use a Linux operating system and go ahead and install Minikube, or sorry here. So these are the set of commands if you want to run it on a Linux machine. These are the set of commands you want to run it on a Mac machine. These are the set of commands which you want to run it on a Windows machine. Okay. So Minikube can be installed anywhere. You have to go ahead and just say where you want this component to run. I went ahead and I told I want to run it here. Basically, an interactive shell is what I've taken from the internet, from the official website of Kubernetes. Not only this, there are other places also where you can get this Kubernetes interactive shell. Kata Cloud is there. So there are many vendors who are just giving their application for you to work on Kubernetes. So you have Kubernetes ready here. If you come here and say Minikube version, so you can see here Minikube is pre-installed, so it will come. Okay, so this is the version of Minikube. I want to check if Docker is there. Docker is there. Kubernetes. So Kubernetes, verifying Kubernetes component. So wait a second, how? Okay, whether Kubernetes is there or not. So I'll just come to know. Now, to interact with Kubernetes, you will need a terminal or you will need an agent. So if you remember this diagram, you need a client. So via this client, you can talk to Kubernetes. You cannot directly talk to Kubernetes. So when you say that client is kubectl for me. Kubectl is Kubernetes controller. So kubectl. So kubectl is the agent, or it is the client who will help me to talk to Kubernetes. So I can say kubectl -- version. So if kubectl version. So I can see kubectl is also installed for me, which is this thing. So I'm all set. Okay. So as I told you, I will not be able to directly interact with my master node. I will be interacting with this client, which is kubectl for me, and I will share all the queries which I have with this cluster via this client.
So the first thing which I'm going to do is I will say kubectl get nodes. How many nodes are there? How many machines are running? So it is clearly telling you there is one machine called Minikube, and that acts as a control plane, a master, and that only acts like a worker node. So on that you have everything. It is running from last 4 minutes 12 seconds, and you can get started with your work. So I told you that kubectl, or for a cluster, the smallest component is a pod. How can I check that? I can come here and say kubectl get pod. So it says no resources are found, or I can say get pods. Okay, same thing, pods. So it says there is no pod available here. Okay, now I need to understand how does Kubernetes deal with containers. So I told you at the very first place that if I have to, or if Kubernetes has to deal with containers, these are containers. But my Kubernetes is not directly dealing with the containers. It is putting a layer on top of this. This layer is called pod. Okay. On top of this pod, there is something called replication controller or replica set. And on top of that, you have something called deployment. And on top of that, there is something called service. So these are the layer of abstraction. Okay. Innermost layer will always be container. Okay. But my Kubernetes is not directly going to deal with containers. So I will put a layer of abstraction on top of that, which is known as pod. I told one pod, one container. Thumb rule should be like that. But there's no hard and fast rule. One pod can have 4 containers, 5 containers. It is your call. But the moment the number of pods increases, the complexity, number of containers increases, the complexity increases. So always one pod, one container. Then on top of that container, you will have one more layer, which is called replica set. Means how many such pods you want to run. So if I say replica set as 5, it means I want 5 pods to run. Okay. Then on top of that, I have something called deployment. Okay. Deployment is the blueprint, which will tell you what is actually going to run. So if you talk at a very high level, you are actually starting your work from deployment only. I'll show you everything. Okay. I'll make you understand everything. Then on top of that, you have service. So let's start with deployment, and then we will drill down and go to replica set, then pod, and then container. So let me just take this out from here and see this guy. So as I told you right now, container is the innermost layer. And on top of that, I will have pod, which is a layer of abstraction on top of my container. On top of that, I will have replica set. And on top of that, I have my deployment. Okay, so deployment manages replica set manages pod, and pod manages container. You can also put it like this. This is what pod stands for. So pod is the smallest unit of work on Kubernetes. It is the layer of abstraction over my container. Usually one pod will have one container. Each pod will get its own IP address like this. Then if I have 2 pods inside one node, this is pod 1, pod 2. So I will get 2 IP address. This is one IP address. This is one IP address. Now let me create a pod and show it to you, whether you are having or whether you get a One second. So this pod can be created. How can you create this pod? Okay, so you can come here, internet, just come here and say Kubernetes. So Kubernetes.io is the official website of Kubernetes. Okay, so it says learn Kubernetes basic. So I'll go to documentation, and here I will look for pods. So it will say pods Kubernetes. Go inside. So if you want to read, it will tell you all the story, what is pod. But if you want to create a pod, you can copy this thing and try to understand what is this. Let's first copy this. It says simplepod.yaml. So I'll also come here and say nano. I'll say pod.yaml. So whatever we are going to do here is being written in YAML. So what is YAML, how it works, that also I'll explain. But just remember one thing, everything will be written in a YAML format. So YAML is strict indentation. What happened? One second. Nano pod dot. Okay. So when I say nano pod.yaml, a terminal like this will open. So like in Windows, you have Notepad, Notepad++, and all those things. Similarly, here you will have a nano editor. You can use VI editor. Come here and paste this thing which you have copied from here. Okay, and then try to understand what is this. So whatever you write on Kubernetes will follow this kind of structure. So there will be first thing, which will be the API version. The second thing will be the metadata, and the third thing will be the specification. So whatever you do, it will follow this standard only. So API version is constant. So you will see that some components will have version as V1, some versions will have V1 beta, someone will have V1 1.2. So it depends when Kubernetes is making a change, they will release a version of that. So any Kubernetes component will start like this, API version. Then they will tell you what is this actually. This is a pod, this is a service, this is a deployment. So they will tell you the kind, what is this? Then in metadata section, you will give a name to your pod. You can give any name. So this guy has given Nginx. You can say Nginx. One, two, three. So this is a name which you have given. Then in the specification section, I told inside pod container will be running. So which container will be running, you will tell. So it is telling that Nginx container will be running. This is Nginx name given. This container will be running and the version is 1.4.14.2. You can come here and say, I want to run the latest version. You can change it, your call. And on what port it is going to run? So port number 80. Very similar to what we were doing in our Docker Compose. We were creating a file like this only. So I say Kubernetes is an elder brother of my Docker Compose. So very similar thing like what is there in Docker Compose, but a little more standardized. API version, the first one, kind, the second one, metadata, the third one, name, and then the specification section where it is telling what container is going to run inside this pod. And it is clearly calling out and saying that Nginx latest is going to run inside this at port number 80. Control X, Y, enter. So this nano pod.yaml is created for me. Now I want to run this. So I will run it like this. kubectl apply. minus F means Docker Compose, Docker Swarm are two different things. Okay, Docker Compose is mostly to solve the network related issues of individual Docker containers. Docker Compose will do that, and Docker Swarm will help you to orchestrate the containers. So what I will do is I will come here and say kubectl apply minus f pod.yaml means whatever I have written inside this pod.yaml, you execute that for me inside the cluster, but I cannot directly talk to the cluster. So kubectl, you go and run these commands for me inside the cluster. Enter. So it says pod nginx 123 created. So now if I come here and say kubectl get pods, I can see nginx 123 container creating. In last 13 seconds, it is running. This time if you come here and see one by one, means you desired for one and I have given you one, and it is currently running. If you want to see a broader output of this, you can say minus O wide. So if you say minus O wide, the same thing, but in a bigger detail. Okay, so it gives you the name, how many pods are running. Okay, what's the status right now, from how much time it is running. The most important thing, this guy, IP address. So when I come back here and say each pod gets its own IP address and a new IP address on recreation. So right now the IP is this, but if I delete this, how do I delete? So rather than saying kubectl apply, I will say kubectl delete pod.yaml or delete minus f pod.yaml. So it says nginx 123 deleted. Let it delete that. And if I come back here and now I say kubectl get pod minus o wide, so I don't get anything. So I'll recreate this pod. How do I recreate? So I'll run this command again. Now again the stuff has been created, but this time if I come back again, you can see, okay, so this IP has been retained because it's a single machine, but in general scenario the IP will not be retained. Okay, so most of the times you will see that the IP will change because I deleted this pod some 40 seconds back and I recreated one. So this is a single machine, so the IP has been retained, but 99% of the times when you are working on a prod-like situation, the IP will not be retained. Okay, so primarily what I want to tell you here is that pod is the smallest unit of work on Kubernetes. It is an abstraction on the container which you are going to run. Usually we go for one pod, one container kind of setup, and each pod gets its own IP address. And the moment you delete that and you recreate a new one, you will get a new container. So let me just try creating one more. And let me just go here and change few things. Okay. So let me say, this time I'm going to create a new pod with the name as nginx. Okay, let me come back here again. Now I can see there are two pods basically. One is with the name as nginx, one is the name with nginx 123. This guy got a different IP address, this guy got a different IP address. Okay, so what I'm seeing here is that the machines, every time I create a new one, I create a new IP address, and these IP address get changed when the recreation thing happens. Now this can cause a problem to you because there are possibilities that the machines or the pods can crash. If the pods crash along with that, the IP also is gone. Now, if the IP is gone, the connectivity is gone. Okay, so pod is running inside that container is running. Container is having a pod is having an IP address. You are connecting via that IP address, but all of a sudden the pod crash, and along with that, the IP is also gone. So to avoid such kind of a situation, we use something called service. So service will do two things for you. One, it will allocate a permanent IP for you, and the life cycle of the pod and the service is not connected. Means the service will stay intact. The pod may get disconnected and then connected again. So what we will do is we will go into service tomorrow. Meanwhile, I'll request you to go into and I'll request you to go and just look into some documents which you can find it over internet and try to understand more about Kubernetes. Kubernetes initially is a difficult topic, is tough to understand, but once you get into the mode of working with Kubernetes, it is very easy and it is very effective. And spending a good amount of Kubernetes will definitely give you fruitful results, undoubtedly. Okay. So on that note, if you have any questions, please go ahead. If you don't have questions, we will stop it for now. My eye purpose something. I could not get this question. May I propose something? Yeah, please go ahead. Yes, there are too many topics to be revised, correct? Okay, so see, anyhow, Friday, Saturday, Sunday, you don't have a class. On top of that, this Black Friday thing is coming, so we will have some break there. So we will be giving you a good amount of breaks, and you can practice that at that time. So I'll go slow as possible. When we will start with JFrog and Nexus, so probably after completing Kubernetes, we'll go to JFrog and Nexus. Okay, thank you. Fine then, see you then guys, bye bye.